Good evening, everyone. This is Mohi from Singapore Maths Academy. Welcome to another one of our 11 plus shorts, where we take you through different questions from past papers in 11 plus found from CSSE exams to independent school exams. And so today we're going to take you through a question that's a challenging question found in the CSSE paper from 2015. Now, the last few questions that we've looked at so far have been all 2015 CSSE paper questions found in their maths exam paper, of course. And what we're going to do after going through maybe another one or two more challenging questions found in this paper, we're going to go through a different paper, maybe an independent school paper, maybe a paper that you recommend to us. So if you have any suggestions, please do write a message below and we will look into that and try to cover that in one of our future videos. So let's jump onto this question and try to tackle this. It says here Anwar is playing think of a number. He does not always think of a whole number. So straight away, it kind of gives us an indication that it's not going to be a whole number. It may not be a whole number. And so decimals and fractions is a possibility here. In each part of the question, work out Anwar's original number. So it says that Anwar thinks of a number. He doubles it and subtracts 17 from the result. He then has 15. What was Anwar's original number? So we can do this in various ways. Okay, so we can, for example, look at it algebraically. We can use boxes. We can use bars. We can use inverse reasoning. And so let's jump onto this and go through it in different ways. So here, Anwar thinks of a number. He doubles it. If we use algebra, his number that he's thinking of is going to be x. And if he doubles that, it's going to be 2x. And from there on in, we can think of the fact that it says he doubles it and then subtracts 17. So then after that, it'd be 2x, take away 17. And as a result, he has 15. So algebraically, you can form an equation which looks like 2x take away 17 equals 15, and solve from there on in. So if we're taking away 17 and then it results in the final answer, or his final number being 15, then we must have been 17 larger before subtracting 17. It must have been larger by 17. So we're going to add 17 on both sides. So we have 2x. So when we doubled that number he was thinking of, it must have been 15 at 17, which is going to be 32. And so when he doubled his number he was thinking of, it became 32, because x is the number that he's thinking of. And so his number that he must have thought of was 32 divided by 2. And so x is going to be 16. Let's see if that works. 16, he doubles the number 32, subtract 17, and you get 15. So it works. So x must be in 16, or in this case, his number he's thinking of is 16. Anwar then thinks of a number. He subtracts 17, then doubles the result. So he thinks of a number, x. He subtracts 17, x take away 17, and then doubles the result. Now, this is where children may find a bit more challenging. How do I represent the doubling? We could do x take away 17, add x take away 17, and that is equal to 15. That's one way we can represent this. Or we could do 2 in brackets and x take away 17. That means we're multiplying x by 2 and negative 17 by 2, and that gives me 15. So there's two different ways we can represent this question. Either way, if we add up and simplify simplify, so we add up here or simplify here, by expanding the bracket, we get 2x, let's write it over here, 2x take away 34 equals 15. And in this case, it looks very similar to the kind of equation that we looked at in section A or 16A. And therefore, we can solve this by just doing exactly the same, which is the inverse operation. And so we get 2x equals, we're going to add 34 on both sides to eliminate this. And so you have 2x is equal to 15, add 34, 15 add 30 is going to be 45, plus 4 is 49. So we've got 2x equals 49, x must be equal to half of that. Well, I know 50 divided by 2 is going to be 25. So 49 divided by 2 is going to be 24 and a half. Let's see if that works actually. So he's thinking of a number. I'm saying his number that he's thinking of is 24 and a half. If that's right, Anwar thinks of a number, he subtracts 17. So 24 and a half, subtract 17, then doubles the result. He then has 15. So 24 and a half. If I subtract 17 from that, I'm left with 7 and a half. If I double 7 and a half, I get 15. And so, yeah, it does work perfectly. So, yeah, for 24 and a half is the value we were looking for here. 16 was the first one. And our final question, Anwar thinks of a number, he halves it and subtracts 17 from the result. He then has 15 again. So if you think about it, x is the number he's thinking of. He halves it. How do I represent that? We could do either half times x, which is half x, or we could do x over 2. Either way, it would be fine. So he halves it and subtracts 17. So half x, take away 17, or x divided by 2, take away 17. And as a result, he has 15. So here, the last thing he did was subtract 17 to get 15. So before he subtracted 17, it must have been larger than 15. How much more should it have been? It must have been 17 more than 15. So x over 2 equals 15 add 17 is 32. And this is where some children may make the mistake. They may decide that they're going to half 32 to get the answer here, right? To get the missing number. But in this case, you can see x divided by 2 equals 32. And so the inverse of dividing by 2 is going to be multiplying by 2. So in order for us to eliminate this division divided by 2, this is half of x. To get a full x, you have to double that. And so x is equal to 32 times 2 is 64. So x equals 64. Let's check again. We always like to check our work. It doesn't take that long. If we have a time in an exam, we would definitely like to do that because it really helps us to eliminate any doubts we have in our mind. So here, we've got x is 64. We're saying the number he was thinking of is 64. And when he thinks of a number, he halves it. So 64 divided by 2 is 32. 32 take away 17 is 15. And therefore, we've also got that one right. Okay, so there are a few questions like this that pop up in the CSSE exams and many other exams as well. These are algebraic by nature. You don't have to use algebra. You can use other methods. So for example, if we have a look at this again, we can just think of the fact that we can just write, we've got a number, we can divide that by 2. And then what do we do? We subtract 17 and we get 15. So we work backwards into the inverse operation. 15 add 17 is going to be, if I add 17 here, what's that going to be? 15 add 17 is 32. So I've got 32. Instead of dividing by 2, I want to multiply by 2. So 32 times 2 is 64. And so we can use a basic method like this, where we're just looking at the inverse operation. So we go along. So first thing he did was he, in this case, divided by 2, halved the number. Then we subtracted 17 and then we get 15. So what do? We work backwards. So last thing he did was subtract 17. So we add 17 to 15 and then we multiply by 2 instead of dividing by 2. And that gives us our initial value, the number he was thinking of. So there are different ways we can look at this. Either of those methods are absolutely fine at this age in 11 plus. We do encourage our children to kind of understand algebra more. However, using any of those methods, you would not be reduced any marks just because you used one or the other method. Hopefully that's helped you with this question and other questions similar to this. If you have any suggestions, please feel free to just write a message below, and we would love to support you and your child's in their 11 plus needs, especially with maths, because we are math specialists. If you have any problem solving questions that you're stuck with, do let us know in the comments below, and maybe we can solve those for you in future videos. And if you have any maths tuition needs, please feel free to contact us at singaporemathsacademy.co.uk. Or if you have any friends that need any maths tuition, whether that's 11 plus, GCSE maths, or even A-level maths, feel free to contact us and we would love to support you. Thank you for watching, and we will see you next week. Take care, everyone. Bye.